Hello everyone. I am Dr. Mahantesh S. Swami, working as Assistant Professor in the Department of Mathematics, Government First Grade College, Jeevargi. This is my first video lecture towards the students of BSc 5th semester studying in various government colleges affiliated to Gulbarga University, Kalburgi. In this video, before going to start my topic, I want to explain something about the pattern of examination which the students are supposed to write at the end of this semester. As all of you are aware of the fact that you are supposed to study only the core papers. That is, the language papers will not be studied in the 5th and 6th semesters. Here you are going to study only the core papers, that is the main papers. For example, if you are a student of PCM combination, you will be studying physics, chemistry and mathematics. And for each of these subjects, there will be one theory paper and one practical. So that will constitute the DSE course. That is, DSE stands for Discipline Specific Elective. In each subject you will be having one DSE. One DSE will have one theory paper and one practical. So as far as mathematics is concerned, there will be three optionals. You can choose one among these three optional papers. So either you can choose complex analysis or graph theory or numerical analysis. Whichever you want, according to your interest, you can choose one of these papers for your study as a main paper, that is DSE in the BSc 5th semester. So the theory paper will be for 100 marks. That will have 80 for examination, that is semester end examination, that will be conducted by the university, and 20 marks will be the internal marks. So in this way, theory paper will have 100 marks and practical is for 50 marks. Again, 40 marks will be the semester end examination conducted externally, and 10 marks will be the internal assessment. So this is how your DSE is going to be one of the core papers in your 5th semester. So likewise, for each of your three subjects, that is for physics you will be having 150, for chemistry or any other subject, whichever you are having, for that you will be having 150 for DSE. So in this way you will be having 450 marks for DSE. Along with the DSE, in 5th semester and in 6th semester you are supposed to study two more papers, and they are called as Skill Enhancement Courses, SEC. So you will be studying two SECs which are of 50 marks each. So two SECs will be there. Each paper will be of only 50 marks, 40 semester end examination and 10 marks for internal assessment. As far as mathematics is concerned, there are 4 optional papers. 4 optionals have been prescribed in mathematics, and out of these 4 you can choose your SEC. So for the entire course, that is for the entire BSc 5th semester, you have to choose any 2 SECs. So that constitute 100 marks of SEC. So 450 for DSE, that is your core subject 3 papers, and SEC, any 2 SECs you are going to choose from any subject of your interest, and for out of the optionals prescribed in your subjects, you will be choosing 2 SCCs, and that will constitute 50 plus 52 examinations you are going to write, each for 50 marks, and that will have 100 marks of SCC, and like that you will be having totally 550 marks of your BSc 5th semester. So this is how your syllabus has been prescribed by the Gulbarga University for your BSc 5th semester. Now in this course I am going to explain you about the one of the important topics of numerical analysis. So I'm dealing with the first that is DSc paper, that is the main paper which you are supposed to study in BSc 5th semester. Numerical analysis, if you have chosen, you will be benefited by this lecture. So numerical analysis is the paper which I'm going to teach you now, and in this numerical analysis paper I'm going to start the first session. So before going to start the first session, I would like to explain you, I would like to introduce you what is the syllabus for prescribed by the Gulbarga University for BSc 5th semester towards the paper of numerical analysis. So there are totally 4 units, and the first unit is errors and solution of nonlinear equations. Second one is solution of linear system of equations. Third one is finite differences, and fourth one is interpolation. So these are the 4 papers we are supposed to study in BSc 5th semester. Now the first unit, that is errors and approximations, that is the errors and the solution of nonlinear equations, I am going to start in this course. So now what are the objectives of this chapter? So this chapter helps us to understand the concepts of errors, types of errors, approximations, solution of nonlinear equations with the help of 4 important methods. These are the 4 important numerical methods which we are supposed to study in this particular first chapter in the numerical analysis paper. Now, as an outcome of this session, what we are going to have? We will be able to understand what is meant by an exact number and an approximate number. And we will also try to know what is meant by the rounding of a given number. That is the most important objective of this session. Now, let us start the session. The first definition I am going to give you about what is meant by the exact number. So, exact number is a number with which no uncertainty is involved or no approximation is made. That type of number is known as exact number. So I hope you understand what is meant by the exact number. Exact number is a number of the type, for example, 7, which is an integral number, and 1/2, though it is a rational number, it is an exact number, because with this number no uncertainty is involved. And even this is the rational number, that is 0.01. It is also an exact number because once again there is no uncertainty involved with this number. So likewise, we are going to define the exact number as the number with which no uncertainty is involved or no approximation is made in that number. So that type of number is known as the exact number. So examples are this type of number: 7, 1/2, 0.01, etc. Now, what is meant by an approximate number? So if we understand What is meant by an exact number? Now we can go for the definition of approximate number. Approximate number is a number which is obtained by retaining few digits of a given number which contain infinitely many non-recurring digits. So if we have a number of the kind 3.14159 dot dot dot, this is an irrational number because it is having non-recurring infinitely many decimal digits. So for the sake of computation, we can retain only few digits after the decimal point. This is the decimal point. After the decimal point, we can retain only few digits and we can ignore all other digits after that. So here what we are doing, we are truncating the number. We are retaining only few digits of a given number, and that type of number, after retaining few digits and ignoring the remaining digits after that, which number we are going to get, that number we are calling it as an approximate number. And therefore, if we consider pi, whose value is 3.14159 dot dot dot. So if we approximate it by considering only 3 digits after the decimal point, so this is how it looks like. So after the decimal point, we are going to retain only 3 digits, and therefore the irrational number pi, whose value is 3.14159 dot dot dot, after approximation it becomes 3.142. So this is the approximate value of this number. Similarly, 2.718 is an approximate value of the Euler constant E, whose value is 2.71828 dot dot dot, like that. So similarly, square root of 2, we know that it is also an irrational number. It is having infinitely many decimal places, and after retaining only 3 digits after the decimal point, we will be having this number. Therefore this is called the approximate number of root 2. So in this work, in this process, that is in the process of getting an approximate number from the given number, an important process is involved, an important work is involved, and that is called as rounding off. So rounding off is a process of cutting off the superfluous digits and retaining as many digits as desired, is known as rounding off a given number. So the number so obtained is called as the round off number. After rounding off the number which we are going to get, that is called as a round off number. Of course, round off number is an approximate number because here we are going to cut down some digits after the decimal place. We are retaining only few decimal places and we are cutting all other decimal digits after that particular place, and therefore the number which we are going to obtain after the rounding off is an approximate number. So how can we do this process of rounding off? It's a very systematic process. It involves certain important steps and it is having a particular rule. And what is the rule and what are the steps involved in rounding off a given number? Let us discuss. So step number 1. In step number 1, we have to observe the digit next to the last digits to be retained. So first we have to fix which is the last digit to be retained. So by fixing that, we have to observe the digit next to that digit. And in the step number 2, we have to keep the last digit as it is. We have to keep the last digit as it is if the next digit is less than 5. This is very important condition. If the next digit is less than 5, we have to keep the last digit as it is. On the other hand, if the next digit, the digit which is next to the digit which we want to retain is greater than 5, if it is greater than 5, then we have to increase the digit by 1. So this is an important thing we have to remember. This is the most important rule which we have to know during rounding of a given number. If the number is less than 5, we have to keep the last digit as it is. If the digit next to the digit to be retained is greater than 5, if it is greater than 5, we have to increase that last digit by 1. However, if the next digit is exactly 5, then the last digit is to be increased by 1 if it is odd. If that number is odd, then it is to be increased by 1. That is, if it is odd, it has to be made even by adding 1. If it is even or if it is 0, then it has to be kept as it is. So this is the thing we have to follow during the rounding of a given number. So let us see some important examples over here. Here, these are the given numbers. Example number 1, example number 2, example number 3, example number 4. These are the 4 different numbers which have been given to us. These are having infinitely many digits after the decimal place, and we have to round off these numbers in such a way that there will be 3 digits after rounding off. That is, we want to retain only 3 digits. So here we want to stay up to here, we want to stay up to here. In this case, we want to stay up to here, and in this number we want to stop at this particular point. That is only 3 digits after, this is first digit after decimal point, second digit, third digit. So we want to stop here. Now how to do this job? So first of all, this is the last digit, this is the digit we want to retain. At this place we want to stop. We have to look at the next digit. So we have to look at this particular point. That is, we have to look at this particular value which is next to 7. That is 4. 4 is less than 5. So when 4 is less than 5, we have to keep 7 as it is. This is according to the rule number 1. If you look at the previous condition, last digit. So we have to observe the digit next to the last digit. If the last digit, if the next digit is less than 5, keep the last digit as it is. So therefore, what we are doing over here, the last digit is 7 that we want to retain. Next to that is 4, and 4 is a number, is a digit which is less than 5. Therefore, we shall keep 7 as it is. So therefore, after rounding off this number, we will have only 0.287. This is here. You can observe. Because the last digit is 4, that is the digit next to last digit is 4, which is less than 5. So we have to keep the last digit as it is, that is 7. So the rounded off number is 0.287. So this is an approximate value, rounded off value of this given number. So this is example number 1 completed. Now let us go for example number 2. In this case, the last digit is 4. We want to stay up to here. We are looking at the digit next to that. So the digit next to that is 8. So 8 is a number greater than 5. When the digit next to the last digit is greater than 5, we have to add 1 to this last digit. So therefore, it will become 4.565. 4 should be made as 5 because this digit, the next digit, the digit which is next to the last digit is greater than 5, so this number, that is 8, is greater than 5, therefore this 4 is to be made as 5. It is to be increased by 1. So therefore we are getting this value as an approximate value of the given number, which is over here. Now let us go for the third example. In the third example, we want to stop here. That is, after decimal point, we want to retain only 3 digits, and we have to look at the digit next to that. The digit next to that is 5, which is exactly 5. Either it is neither greater than 5 nor less than 5. It is exactly 5. Now what is to be done? The last digit, if it is odd, we have to make it even by adding 1. Therefore, it will become 4. This 3 is to be made as 4, and all other things previous to that will be as they are. So the rounded off number of this given number is 21.014. 3 has been made as 4 because this last digit is increased by 1, because the digit next to 3 is 5 and 3 itself is an odd number. According to the procedure, it has to be made as even by adding 1. That's what we have done here, and we have rounded off the given number and got this approximate value. Similarly, when we look at this fourth example, in this example, the last digit to be retained is 4 and the digit next to that is 5. So when the digit next to the last digit is 5, we have to look at the digit itself, the last digit itself. If it is odd, it is to be increased as we have done in the previous example. But if it is even, then nothing is to be done. Keep it as it is. So therefore, the rounded off number of this given number is 7.024. So this is the approximate value of the given number. So like this, we can work out many examples on rounding off a given number. So this is the thing which I wanted to share with you in this first session. I hope you have enjoyed it. And there are several examples, several questions you can answer to these questions. These are, you try it within a moment, you can answer to this question. So what is the approximate, what is this type of number? What is this number? Yes, there are 4 options. You please answer to this question later on. So you can write your answer in the comment box. So please go through these multiple choice questions. Try to answer these questions. You can have the questions afterwards, and you please rewind the video and try to solve these questions. So with this I want to conclude. So this completes my first session, and for this chapter, for the entire numerical analysis, you can refer a textbook written for the use of Gulbarga University students by me. I have written this textbook and it has been published, and it is now available as UG Mathematics 5C Numerical Analysis. So please look at this book and try to solve more and more examples. So see you next time in the next video. Thank you.